All right, let's dive into an incredible feat of modern engineering. We're talking about the construction of one of the world's largest, most advanced, and, believe it or not, most eco-friendly container ships ever built. But look, this isn't just a story about some big boat. No way. This is about a truly revolutionary vessel that completely smashed the limits of what we thought was possible in engineering. It's a project that basically redefines what it even means to build on a colossal scale. So, just to give you a sense of that scale, let's start with a number. 6. That's how many Olympic-sized swimming pools you could fit inside this ship's fuel tank alone. We're talking about a capacity of nearly 20 million liters of fuel. I mean, it's a number so big it's almost impossible to wrap your head around. And the ship itself, get this, it's 400 meters long. So you could take 4 football fields, lay them end to end, and that's how long this one vessel is. It is a true giant of the seas. So yeah, let's really break down the mind-boggling numbers that define this whole new era of shipping. Seriously, the stats behind this vessel are just staggering. So what can a ship this big actually carry? A jaw-dropping 23,112 containers. Now, to put that into perspective, if you were to lay all of those containers in a single line, they would stretch for 150 kilometers. Think about that for a second. And what about the weight? Well, even completely empty, I mean not a single container on board, this ship weighs 70,000 tons. That's like 7 Eiffel Towers. Or, if you prefer, about 11,500 African elephants. It is just an immense, immense structure. Okay, but why? Why build something so enormous, so complex? Well, that brings us to the core problem the ship was designed to solve. See, it's not just about getting bigger anymore. You see, for decades, the name of the game in shipping was just build bigger and bigger and bigger. But we've pretty much hit a physical limit. A ship can only be so large before it just can't fit through crucial waterways like the Suez and Panama Canals. So the industry had to pivot. They had to change their focus. And this right here is the crucial point. The new frontier isn't about size anymore. It's about sustainability. The real competition now is to build the most fuel-efficient and eco-friendly ships on the planet. And this vessel, it represents a massive leap forward in that race. So how do you even begin to build something on this scale? I mean, you can't just build it in one piece. You have to build a mountain in pieces, using this really ingenious process called modular construction. So the whole idea is to build it in these massive prefabricated sections called blocks. It all starts with over 12,000 steel sheets. And these aren't just cut with anything. They're cut with a laser that's 3 times hotter than the surface of the sun. Yeah. These sheets are then welded together into blocks, and some of these blocks are as big as multi-story buildings, with all the wiring and piping already installed inside. And this right here perfectly illustrates the core engineering challenge. On one hand, you're dealing with just raw, immense power. I mean, this rear section weighs 790 tons. It takes 2 giant cranes just to lift it. But on the other hand, you need delicate, almost microscopic precision. We're talking a mistake of just 1 single millimeter could compromise the entire ship and waste months and months of work. So once those massive blocks are in place, an army of welders gets to work. And how much welding are we talking about? You're not going to believe this. On a single ship, there are 1,250 kilometers of welds. Stretched out, that's a line that would go all the way from Karachi to Lahore. And every single inch has to be meticulously checked, because out on the open ocean, the waves are absolutely relentless and unforgiving. But honestly, the real revolution in the ship isn't just its size or even how it was built. It's what powers it. So let's talk about the ship's, well, its cold heart. Its liquefied natural gas fuel system, or LNG for short. And this brings us to what was probably the single biggest engineering problem of the entire project. See, the fuel needs to be kept incredibly cold, so the team essentially had to figure this out. How in the world do you build a giant, high-tech thermos, the size of 6 swimming pools, and put it right in the middle of a moving ship? So what exactly is LNG? Well, it's natural gas that's been cooled down to a mind-bogglingly cold -161 degrees Celsius. At that temperature, it becomes a liquid, and that's the key to its efficiency. But keeping it that cold is a monumental challenge. I mean, if it heats up even a little, it turns back into a gas, expands, and it's game over for the whole system. So why go through all that trouble? Well, the environmental payoff is absolutely huge. Compared to the dirty, heavy fuel oil that ships normally use, LNG cuts sulfur dioxide emissions by 99%. It cuts overall air pollution by 91% and carbon dioxide by 20%. This is a massive, massive step towards cleaning up global shipping. So how did they pull it off? After months of work and packing in layers and layers of insulation, the final piece of the puzzle was this: a special wavy steel membrane that's only 1.2 millimeters thin. When that super cold LNG hits it, the steel shrinks. But the wavy design allows it to contract and then expand again without breaking. It's an absolutely ingenious piece of technology, originally adapted for materials used on the International Space Station. But the innovation doesn't stop with the fuel tank. Not at all. Let's move on to the engine and the propeller, because this is another area where you see unbelievable power meeting absolute pinpoint precision. Just look at these numbers. The engine's crankshaft, that's the part that transfers all the power to the propeller. It weighs 220 tons all by itself. The propeller, that's a 92-ton single piece of cast metal. Heck, even a single link in the ship's anchor chain weighs 300 kilograms. We're talking about truly incredible, almost unbelievable weights here. Okay, so how do you make sure these massive, super heavy parts fit together perfectly? Well, you use a surprisingly simple, almost old-school method called the blue dye test. They literally coat the propeller shaft in a special blue dye, fit it into the propeller, and then pull it back out. The dye shows them exactly where the two surfaces touched, and more importantly, where they didn't. This lets the engineers make these tiny micro-adjustments to prevent catastrophic vibrations when the ship is at full speed. All right, so after a year and a half of non-stop work, of bringing all of these incredible pieces together, the final moment arrives. The ship is finally ready for its ultimate test. It's ready to prove it can rule the seas. So that first ship was completed after 18 long months of tireless effort. It then went through 15 days of grueling sea trials where they tested everything: engine speeds, emergency brakes, navigation systems, you name it. And after it passed with flying colors, the shipyard did what seemed impossible. They delivered a total of 9 of these revolutionary ships, all in record time. You know, in the end, this isn't just a story about a mountain of steel. It's really a story about people. It's about the intelligence and the tireless effort of thousands and thousands of workers. It's proof that when human ingenuity and sheer determination come together, we can move mountains. Even mountains made of steel across the most unforgiving oceans on Earth. Thanks for joining me.